everyone, we are back. Welcome back from break. Hope you guys had a great time off and we're getting back to it. So yes, these videos, not everyone's favorite, but we just have to get it done this year. Okay, so follow through, get them done on time, and let's do this. Day 1 and 2 are one video. Okay, so that's one video. Day 1 and 2 is just put together because Pythagorean Theorem you did before break. And then we're going to classify. So that's just going to be put together in one video. So this is the plan for the next month. Okay, and then your tests are looking on the 18th and 19th. So this is a pretty big unit. There's 7 days. Very important. And let's get after it. All right, so let's remind ourselves what Pythagorean Theorem is. That is a squared plus b squared equals c squared. Again, the legs can be interchangeable. And then c is, again, the hypotenuse. Okay, remember you square them separately and then add it together. And it should equal c squared. So let's solve these, 1, 2, and 3. And let's go. All right, so A and B, and we will have this be C. This is the longest side. It is across from the 90-degree angle. So making these kind of notes is very helpful. So 6 squared plus 4 squared equals x squared. We want to find out what that side is. So 6 times 6 is 36. 4 times 4 is 16, and that equals x squared. Now I'm going to add them together. So 36 plus 16 is 52, and that equals x squared. Again, I'm not going to have a side of 6, a side of 4, and a side of 52. That wouldn't make a right triangle. We want a right triangle. So what I need to do is do this square root button. The opposite of squaring is square rooting. So I want to find the square root of 52. Okay, so roughly square root of 52, trying it in your calculator, is 7.2. Okay, so roughly, if you make this little, that means estimate or approximate. Okay, approximate is what this little wavy equal sign is. Okay, so 7.2. All right, now try number 2. So A, B, and C across the way. So I have x squared plus 5 squared equals 13 squared. So x squared, bring it down. 5 squared, 5 times 5 is 25. 13 squared is 169. Well, how do I get x squared by itself? Well, first I need to move this 25. So I'm going to subtract 25 to both sides. And x squared equals, so 169 minus 25 is 144. Square root both sides. And x equals 12. Again, it's an equal sign because it's perfectly 12. There's no decimal. All right, I want you to try number 3. So if I have a squared plus b squared equals c squared, label a, b, and c, and solve it for, in this case, this y value. So think about, where is that y value? Is it the a, the b, or the c? Again, a or b, it doesn't matter if it's a or b. It's just one of the legs. So try that and check back. So after you subtract, you should square root both sides because you're solving for one of the legs, and y is roughly 13.3 when you round up because it's 13.26. Okay, so that's the answer for y. All right, now let's solve this one. So it says the distance, so the base of the ladder to the wall, so this section right here is 1/4 of the ladder itself, and the ladder is 20. Okay, so I need to find out what the distance of this is first. I'm going to do 20 times 1/4, multiply across, 20 over 4 equals 5. So then we have 5 feet down here. We've got the 90 degrees here, so that means that the 20 is my C. So I have, again, a squared plus b squared equals c squared. This side right here that we're looking for, the wall, that can be the A or the B. In this situation, let's make it the B. Why not? And we'll make the 5 the A, and 20 has to be C. It's the longest side. Okay? So I have 5 squared plus x squared equals 20 squared. So 5 squared is 25. 20 squared is 400. Subtract 25 to both sides. And I have x squared equals 375. Okay, this is the part where people are like, oh, that's not any of my answers. I can't have a wall that's 375 feet. No, it's going to be way up there, and it's not going to make a right triangle. That's our mission, right triangle. Okay, so what do I need to do? Square root both sides. So find the square root of 375. And I've got 19.3, 19.36. Well, what is the closest to that? That's B, 19.4 feet. All right, now let's remind ourselves about the converse, okay? So in this situation, that's the opposite. So instead of knowing it's a right triangle, in this situation, we don't know if it's a right triangle or not. So we have to prove it. So if a squared plus b squared equals c squared, then it is a right triangle. Excellent. Okay. All right. So we have to prove it and make sure that it works. So we're going to do 3 problems and say yay or nay if it's a right triangle. The biggest side is going to be C. The other 2 sides are A and B. So 10 squared plus 5 squared equals 12 squared. Let's see if they equal. So I'm going to put a question mark in between and see if they equal. Question mark, because we don't know if they equal or not. So 10 squared is 100, 5 squared is 25, 12 squared is 144. Now let's see if they equal. So does 125 equal 144? That's a no, so not a right triangle. Okay, now let's try number 2. So 13 is my biggest side, A and B. 8 squared plus 7 squared, question mark, 13 squared. So try this out, see what you get. So 113 and 169, those do not equal. So that's a no. Again, not a right triangle. Okay? All right, the last one. I'm going to kind of switch this up. So I want the longest side to be 10. I want one side to be 6 and one side to be 8. Just for the sake of right now, I don't want to really deal with radicals. We'll deal with those later on. Okay, so I want you guys to try this problem. What's the longest side? Well, that is 10. So 10 squared. And then we're going to see if the other 2, you have to square them first and then add them. So 6 squared, 6 times 6 is 36. 8 squared is 64. And that equals 100. Well, 10 squared, 10 times 10 is 100. So do these equal? Yes. 100 equals 100. Yes, it is a right triangle. Excellent. So we solved for one side, and we also proved whether it's a right triangle or not. All right, that's all day 1. Let's move on to day 2, because again, we want to remind ourselves, so if it's not a right triangle, there's 2 other types of theorems. Well, acute theorem means that c squared is less than a squared plus b squared. So in a lot of situations, we don't have a right triangle. We have maybe an acute or an obtuse triangle. So if c squared is less than a squared plus b squared, so 2 of the legs are bigger than the big leg, then you have an acute triangle. There we go. So what really matters is the symbol. So the 2 legs are bigger than the hypotenuse. Okay? All right, for this one, well, what would be the opposite? Well, if c squared is greater than a squared plus b squared, then you have an obtuse triangle. Okay? So greater then you have an obtuse triangle. So if hypotenuse is bigger than the 2 other legs added, then obtuse. If it's less than, you have acute. So let's rock these out. So, all right, so we're looking at different combinations and see how would we get a right, an acute, and an obtuse. Well, let's think of different combinations. So 8, 14, and 17. So if I did 8 squared plus 14 squared equals 17 squared. Again, the biggest side, I'm going to put the biggest side as my C and see what I get, okay? So 8 squared is 64, 14 squared is 196, and 17 squared, again, you need to be practicing this in your calculator to make sure you know how to do it, is 289, okay? So 64 plus 196 is 260. So these added together is 260 and 289, okay? Well, is 260 greater than or less than 289? Believe it is less than, okay? So what would that mean? That would mean that C squared is greater than A squared plus B squared. So that would be an obtuse triangle. So the combinations of 8, 14, and 17 would give you an obtuse triangle. Okay, now let's look at a different combination. So what if I had 8, 17, and 20? Okay, so let's try that combination. Okay, and see what we get. Again, you have to square each of them. If you just add them, that's not a triangle. That's not Pythagorean Theorem. We have to square them. We have to square each one and see what happens. So I have 64 plus 289. Question mark, 20 squared is 400. Okay, so 64 plus 289, well, that's 353. So again, I have 400, which is greater than 353. Well, let's step it up a notch. So that's another obtuse triangle. All right, how would I get an acute? Let's think of the different combinations in order to see what we can do. So let's try 14, 17, and 20 and see what happens. Okay, so 14 squared is 196, 17 squared is 289, and let's see if that's greater than 400. So 196 plus 289. That's 485. So 485, yes, that is greater than 400. Okay, good. So again, when you have word problems, you gotta have to bend and weave and see what's going on. How do we group these together? So to make acute, meaning that A squared plus B squared is greater than C squared, that combination is 14, 17, and 20. Okay, now the last one, we have to see, do any of these combinations make a right triangle? So for a right triangle, I already did, so the combinations I already did are 8, 14, 17. I did 8, 17, and 20. I did 8, 17, I did 14, 17, 20. Okay, is there any other combinations? I don't think so. So none. None would make a right triangle. None of them are equal to either side. Okay? So again, for B, there was a combination of 14, 17, and 20. For the obtuse, we actually had two of them. We had 8, 14, and 17, and 8, 17, and 20. So your guys' brains all mush already. Because again, we're just trying to combine the different ones and seeing what type of triangles we can get. All right. So, sorry there's no 1, 2, or 3 on here. We're just doing the best we can, guys. So you can rewrite this and say that this is 1 through 3 if you want to. Sounds good. All right. So classify the triangle as acute, obtuse, or right if possible. Again, the biggest side is C. So let's see. So 5 squared plus 12 squared. Let's see if that equals, or what is the symbol for that. So 5 squared is 25. 12 squared is 144, and 13 squared is 169. We're going to add up the A and the B, and we get 169, which equals 169. If they're equal, it is a right triangle. Okay? All right, for the next one, 6, 12, and 20. So 6 squared plus 12 squared, question mark, 20 squared. So let's see what happens. 6 squared is 36. 12 squared is 144. What is the combination of the 400? So 36 plus 144 is 180. So in this situation, the 400 is bigger, so it's going to be eating the bigger number. So what kind of triangle is it? It's going to be an obtuse triangle. So again, if the c squared is bigger, you've got an obtuse. All right, so we've got a right triangle and an obtuse triangle. Fantastic. All right, the last one. Oh man, this one's tricky. Number 8. I'm going to actually cross out 9. Well, yeah, we have to kind of, cross out 9, but we'll work on number 8 together, and then you'll do 5 and 7. Okay, so the square root of 170. I don't know really what that is, so let's figure that out. 170. All right, so that's 13.03. So this is the biggest side. So you're going to do the square root of 170 squared. Okay, and then I have 1 squared plus 13 squared. And we're going to see if these equal or not. Okay. Well, let's remind ourselves. The opposite of multiplying is dividing. The opposite of adding is subtracting. Okay. The opposite of squaring something, like we've been doing, is square rooting something. Okay. So what happens is when I square a square root, these cancel out and I have 170 left. Okay. 1 squared is 1. 13 squared is 169. So 1 plus 169 is 170. Oh, look at that. And that equals 170. Good. So this is a right triangle. Okay. We haven't had any acutes left. Remember, the acutes mean that a squared plus b squared is bigger. Okay. So I want you to try 5 and 7. Work them out and see what you get. So number 5 is an obtuse triangle and number 7 is an acute triangle. Okay? Nice work. So that's all for this day 1 and day 2 put together. Okay? Make sure you stay on top of your videos, ask questions in class, and have a great day.